Hi everybody, welcome back to day 2 of our Media Week NYSE Wired and theCUBE's community. This is our AI Innovators and Cyber Week. Dr. Sherry Marcus is here. She's the Director of Applied Sciences at AWS. Sherry, great to see you. Thanks so much for coming in.
Thanks, it's great to be here. What a great spot.
Yeah, it's amazing, isn't it? We're just coming off of reInvent. We got the fire hose of content. You are focused on Bedrock Innovation. Tell us about your role so we can frame the conversation.
Yes, so I lead science for Bedrock. Bedrock, as you know, is AWS's generative AI service where customers can choose from one of many models to build out a Gen AI application. My team's role is building out the components of these applications, such as guardrails, agents, RAG, distillation, and intelligent prompt retrieval, amongst many other things.
So a lot of that stuff got announced this week. So I want to start with Bedrock. So people think of Bedrock, okay, just a place to get models, it's like a model garden, but it's much more than that. What's the science behind Bedrock? You mentioned several sort of innovations, agents, distillation, model distillation we heard this week is now part of that. Guardrails, super important. Let's get into that a little bit. Tell us about the science.
Yeah, so our science is really focused around 3 common elements about which what customers want, okay? Customers want models that are highly accurate. Customers want models and applications that are fast, have very good latency, and customers want applications that are cost effective. And so the capabilities that we build, using our science, tries to minimize or maximize those 3 different functions. So for example, distillation is about using a large model and teaching it all of its knowledge to a smaller model for given types of tasks. And therefore, customers are able to use these small models and get the same performance or accuracy at a larger model, but these smaller models are faster, so they have lower latency, and they cost less.
Your premise as a company is that you've got to have model optionality.
Yes.
There will not be one model to rule them all.
Yes.
You're right, customers want accuracy, they want speed, and they want it to be cost effective, and I think I'm inferring there are trade-offs, obviously.
Yes, there
between
are.
those. If you want a model to be this perfectly accurate and the highest performance, you're probably not going to have the most cost-effective model. But then there are ways to, as you say, distill models, and so you've got to have a broad selection. In fact, we saw that with Nova. I was struck by how many options of Nova there were. It was actually somewhat overwhelming, and when you combine that with all the other models that you have, whether it's Anthropic or Mistral, et cetera, so many choices. How do you help customers decide what the right fit, right strategic fit for their application? Is that part of the science?
Yes, it is, and I'm so glad you mentioned that, because we also released new features at reInvent called model evaluation and knowledge bases evaluation. And so with these new features, customers can take any model on Bedrock and evaluate it for their specific features and functionalities that they're looking to produce. And as such, they can take, for example, 10 or 20 examples against all of these models and figure out which models has the highest accuracy or the lowest cost. And then they can start building out different types of applications.
This model distillation is interesting. If I understand your description, you take a large model and then you're able to distill it down to a smaller model, like I'm imagining a chef, reducing, to get the really, the fine ingredients. I've read papers. There was a paper by OpenAI, I think, earlier this year that talked about smaller models being able to prompt and train larger models. I wasn't sure if that was it didn't kind of intuitively make sense that a small, but then I thought, well, maybe it actually can prompt better than a human. From a science standpoint, are you seeing I guess my question is how is the interactions between models advancing the efficacy of models?
So what I'm seeing, all right, is that larger models are essentially being used to train smaller models, to be more performant for given tasks. And that's the trend. And the way it works, by the way, it's just supervised learning, right? You take a set of prompts and responses that is generated by the teacher model, right? And then you use that to instruct the smaller model over time. Now, what our secret sauce is in Bedrock, is we use something called data augmentation, where we're generating more prompts and responses from the teacher model to train the smaller student model, and getting better accuracy as a result of it. Now, to your point on OpenAI, you can use like very well fine-tuned smaller models to train larger models, but there has to be a business case in order to do it.
Yeah, it sounded like a bit of a science project, but as a scientist,
Yeah.
it's okay to do science projects sometimes. But
Yeah.
but you're an Amazonian, so there's got to be a business case around
Exactly.
it.
Exactly.
I get it. Can you talk scaling laws with me at all? Is that something that's in your swim lane? Can we chat about that a little
Sure,
bit? Okay,
sure.
so let me frame it, and then you can course correct. So
Okay.
I think many people are familiar with scaling laws. Compute. You've got to have data, you've got to have parameters, which are
Right.
the weights and biases. Try to scale one without the other two, you get diminishing returns. So if you really want to get results, you've got to scale all three together. So my understanding now is the world is waiting with bated breath to see what comes out of Colossus with this 100,000 GPU clusters. Will the scaling laws hold? Right? This
Yes.
is what we're all waiting with
Yes.
bated breath. Nobody thought it could be done. Now all of a sudden, pre-Blackwell, we're seeing
Yes.
some potential here. How should we think about scaling? Some people say we're running into limits. Others say, oh no, we're just getting started. What's the real story?
Well, so this goes, the first observation about neural networks, okay, and scaling laws actually comes from someone in Andrew Ng's lab at Stanford, and how he founded Google Brain, which was, he noticed that the larger the neural network, the more accurate the results are. So let's scale these neural networks. Now they're large language models, bigger and bigger, to get these more fantastical results, from larger and larger models. The answer is, I think there's more out there. I think with the Blackwell, we're going to be able to get more accurate results from larger and larger contexts. I think there's a lot of room, to grow there. I think, though, that the market has to absorb the models that we have now as well, and really understand how to use it. So I think the message I want to send is that the science is way outpacing, what industry is absorbing, as is to be expected.
I have another question, and again, if I'm out of your swim lane, let me know,
Sure.
but you've got a pretty wide observation space. Think about Nova. You think about, okay, I guess my question is, why does Amazon need, it's got so much optionality, it's made big investments and commitment to Anthropic. Why does the world need a Nova, and why does Amazon need to be in the model building business? There's got to be some kind of business justification there. Is that something that you can address?
It is, and it was the #1 question that I was asked at reInvent as well. But look, customers have come to us and says, we want models at cheaper prices. All right, they're very expensive to run at scale, and we heard them. And so as a result, we built the Nova class, which is on average 75% cheaper, than other, models, competitor models on Amazon. And as you see from, the results, they're about just as accurate. So the message really is more for less on these Nova models, and it's something that historically AWS, has always done. Give the customer more capability at less cost.
Well, we had Andy Jassy on at reInvent, and we kind of were having a side conversation with him about this. And it struck me, how Amazon likes to be, it's comfortable being misunderstood for long periods of time.
Yes.
And I think the last 2 years, Amazon's been misunderstood. But at reInvent, it became crystal clear. You're basically taking what you did with Graviton, and Graviton is to x86 as Trainium is to, big NVIDIA GPUs. So you're giving lower cost
Yes.
options there. And based on what you said, and we kind of got this, I think, right, is that what you're doing with Nova is similar. You're taking
Yes.
that same mindset of, hey, we can develop IP internally that will lower customers' cost and still preserve their options.
Exactly, exactly. It is the more for less, philosophy. I would say that Graviton was built on an ARM architecture, whereas the Trainium series was new, but the analogy still holds.
Oh, actually, I didn't know that. Trainium's not ARM-based.
No,
I never knew that. And Inferentia is as well?
that's right. To the
So
best of my knowledge.
Okay. I maybe missed that. All right, we'll
Okay.
check that.
Okay.
But it's still coming out of Annapurna
Yes,
Labs,
yes,
one of the
yes,
greatest
yes,
acquisitions
yes.
in the history of tech. If you don't know Annapurna Labs, check it out. So much is happening in this space. I
Yes.
want to ask you about accuracy and guardrails.
Yes.
So sometimes they're counterpoised, right?
Yes.
How do you square that circle?
That's a great question. So let me give examples of how customers use guardrails and to kind of explain the accuracy. A lot of customers use guardrails for denial of topics, meaning that they only want their customers to ask questions about what's relevant to their business. So if you're in airlines, you don't necessarily want customers asking, what's the latest news,
Yep.
So we restrict, topics only to specific, areas. Now what comes out is that sometimes, language is imprecise, topics overlap, and you may get hit, where a customer asks, an airline question, a question about the weather, and it could inadvertently, construe that as, not relevant, to the topic. And so what we do is, the customer has all of the transactions in their own audit, in CloudWatch, and they're able to continually tune and train, the guardrails so that you maximize, the accuracy.
The other interesting thing I wanted to ask you, again, this came up in the Jassy conversation,
Yeah.
is I think it's pretty clear that you guys are in a position to train models. I think you mentioned this with Anthropic. I think you said hundreds of thousands of GPU clusters
Yes.
are going to be able to you'll be able to train on Amazon infrastructure.
Yes.
So we're talking about Amazon's back-end network and the associated tooling around it. And you've been working on that for a while. This is, again, goes back to the misunderstood. So I think I'm right, and you can do that without InfiniBand. You're doing it with your own Ethernet or network or whatever you call your network. I forget what the brand name is, but it's your IP.
Correct.
Again, lower cost of not only better margins, but lower cost for the customer as well. You can pass that on. Did I get that right?
You did.
That's
And
big.
It is big. It is big. It is big.
So I'll say it this way. Because you have Trainium, and I guess Inferentia too, you were able to, over the past couple of years, get on the S-curve, the learning curve of the tooling and how to train without being 100% reliant upon NVIDIA infrastructure. Others were more GPU constrained, so they had to dole out GPUs. They weren't able to apply probably as many use cases. So it brings me to agents, because we see a lot about, particularly Microsoft, a lot of copilots,
Yes.
a single copilots. You have Mark Benioff talking about Clippy, which is fun. But the point is, Microsoft, and you won't talk about Microsoft, but I will, they were constrained on GPUs because they don't have the experience that you guys got starting in 2015 with Annapurna.
Yeah.
So you were able to more widely apply the technology and learn more. So it brings me to agents, which is something I know you know a lot about. It seems to me there's a lot of agent washing going on, there's some real gaps in what has to happen in order to make agents deliver on the promise. One being the harmonization of the data. And I'd like to really push you on this, Sherry, because I feel like Amazon customers have data in the cloud.
Yes.
And they have probably better data than most, but I feel like it's still disparate. It's across multiple data stores, and it's still, I would think, a challenge to harmonize. How are you solving that problem internally to support your agentic frameworks, and how are you helping customers solve that problem? Does that make sense?
It does, it does. You know, I have a different perspective.
Please.
The secret sauce, okay, behind making agents, work from a science perspective is taking the natural language, the prompts from humans, and converting that into a system instruction, okay, that the agent understands. And that translation, okay, that prompt optimization is very, very tough to do. We see how everybody writes prompts. Sometimes they're good, sometimes they're not, right? Now, once we're able to do that is really where you're speaking about the data harmonization and making sure that, we're accessing the right APIs, for the right data, to retrieve the right content to bring back to the agents and get a good result. Today, we are building out lots of new connectors, all right, to lots of different data stores. This was announced at AWS, reInvent, to be able to begin to get that harmonization, both internally, and externally. But it really comes down to what we call tool use and being able to access, these different databases, have it retrieved by the agent, which would then convert to an answer.
Is this where Knowledge Graph comes in? Because you guys have a Knowledge
Yes.
Graph capability, and that seems to me to be an emerging, I don't know if it's a feature or a tool or a market, it could be all three, but it seems like it's a linchpin toward that harmonization.
It is, because what the Knowledge Graph does is you have a RAG application and it will take out different chunks, okay, of data from all these different places to retrieve. And what Knowledge Graphs do is they connect them, all right, based on common, entities or names, and then they, bring them back together, in a coherent format. And that kind of knowledge graph helps provide more accurate answers, more complete answers, and more creativity, actually, in the LLM's responses.
So, how do you think about the promise of agents? It seems like we are entering a new era of potentially productivity. There's obviously concerns about jobs and so forth, but productivity and growth could go through the roof as we enter this AI era.
Yes.
How do you think, what is the potential of agentic AI?
Yes. I think we are just getting started, and have yet to build out, and realize its full capability from a science perspective, as well as industry is just getting started. The applications I've seen in agentic systems have definitely been in the call center, domains, where it has increased containment, meaning that more generative AIs are able to accurately answer questions. I've also seen, but that said, there's more calls, okay, continually coming. I've also seen a lot of success in code development, and agents coming back with different suggestions for a feature development or a code transformation. And those seem to me to be the lowest hanging fruit from what I've seen in the market.
Interesting. I mean, you mentioned Connect. Again, I bring up Jasty, sounds like I'm name dropping, which I am shamelessly. But we learned so much, Andy's amazing. You
Yeah,
just
he is.
have a half-hour conversation with the guy and like, wow, I just learned like 20 things. But my point is, Amazon's applying a lot of its own, I call it dog fooding, probably call it drinking your own champagne or something,
Yes.
but applying its technology internally
We
at
do.
a massive, massive, massive company that you can then, like you did with Connect, point externally. This is where I think agents have such a tremendous opportunity, and Amazon's in a position to really educate and facilitate that adoption. I mean, there's got to be hundreds, if not thousands, of use cases internally, many of which could turn into either services or software products that you can point at customers.
100%. In fact, we've done some of that with some of our intelligent prompt routing that we released at reInvent. So we have our internal, tech knowledge bases where, techs can ask questions about what services should I use for what. And using prompt routing, a lot of queries are just very simple. And we found statistically that 40% of such queries are simple. And you can route those, queries to a small model and, gain cost efficiency. And so we're beginning to look into that right now at Amazon ourselves.
Sherry, I've gone way over my time. Thank you so much for coming here, and appreciate all your insights. Love to have you back.
I'd love to.
You're local. We're down here a lot, so thank you again.
My pleasure. Thank you.
You're very welcome. Okay, and this wraps up day 2. This is Dave Vellante for John Furrier, NYSE, Wired, and theCUBE's Media Week, AI, and Cyber Innovators. We'll be back tomorrow with more great content. Thanks for watching, everybody. We'll see you shortly.
Thank you.